Hello guys, this is Brewman here. Welcome back to another video, and today I just want to talk about one of the stupidest theories I've ever had. And it's something I do kind of still believe to this extent, but yeah, I'll just talk about it. Now, originally this was going to be a rant on my main channel. I probably will do a rant about it sometime in the near future, but yeah, I just think it'll be quite funny. And I think a video format like that, this is going to be a bit better. I'm also going to edit a bit, as you will see in this video, although yeah, if you're wondering what the theory is, it's that the moon is a planet. Yes, this thing is a planet. Oh, I also love it how it says Earth, then moons, then moon. I don't know, there's something funny about that. But yeah, anyways, what I'm gonna do in this video is that you see, this is a theory I had, which wasn't necessarily unjust. I had my own reasons for it, so I'm gonna explain it. Some of the issues with those reasons, which I actually haven't only even thought about recently, and what I think should happen in the future, because I think this actually might be a problem when it comes to classification of moons versus planets. So yeah, anyways, let's get started. But anyways, right before we get started, I just want to notify you all we now have a brand new Discord server. So if you're interested in this channel, you want to be part of the community, make sure to go into the link in the description down below and join my Discord server, and I'll see you there. So now, when did this theory start? Well, it started when I was in 10th grade, and if you're wondering, this is actually something which apparently has been debated at NASA. Now, I am going to talk about this a bit later when I talk about why the moon isn't considered a planet, although this is actually a controversial thing. Kind of. Most people, most normal people say it's a moon, but of course there has to be people like me. Now, when you heard that about moon being a planet, your first thought is, wait, but the moon orbits the Earth. The Earth does not orbit the moon. Why is the moon a planet then? And for that, I say that you're actually completely wrong, weirdly enough. So in a very cursed way, not only does the moon revolve around the Earth also revolves around the moon. And the sun revolves around the Earth. Now, this is Kepler's Law of Gravitation. I had to look it up. I forgot the name of it, but basically what it states is that when you have two objects, even if one's completely orbiting another, basically they share a common central focal point where both of them orbit around. And this focal point is dependent on both mass and radius. Not radius of the objects, but the distance in between them, I meant. So basically what happens is, in most cases, you have an object which is just so much larger than the one orbiting it that that point is almost directly dead in the center of the larger object. But that's actually not the case with the Earth and the Moon, weirdly enough. Now, I did some looking up, and I found that all of the sources will be in the link in the description, of course. And I had a relative idea of where everything lied down, although I wanted exact numbers for this video. So, the Earth's core, or the barycenter, which is the center of gravity between two different objects, is around 2,900 miles from the Earth's core. Basically, in other words, that's how much the Earth is revolving around the moon. And when you look at the radius of the Earth, its radius is 3,900 miles, or 6,300 kilometers. Now, what that means is that the point at which basically the barycenter, the point at which both the Earth and the Moon orbit around, is still inside the crust, although it's very close to escaping. And that's something to keep in mind. This is a model which I'm kind of trying to explain about. This is a good depiction of what's happening, although the distances, as you can see, are not quite to scale. Now, where you see the barycenter compared to Earth's surface is roughly to scale, although like the distances in of themselves are not. Something else to keep in mind is that the moon is roughly 1% of the Earth's mass. If you're wondering, it's actually almost exactly 1.23%, which on a human scale might seem really tiny. But the thing is that on an astronomical scale, 1.2% or 1.23% is actually really huge. That is definitely large enough to cause orbital disturbances like I'm talking about right now. Now, you see, this really kind of applies with any planet, although the thing is that depending on where the barycenter is, a system of planetary objects could be considered a binary planet. Now, what a binary planet is, it's technically two objects revolving around each other. Now let's take a look at Pluto, and apparently they don't have dwarf planets on this model. What the hell? I could have sworn they did, or is that like some sort of option? But weirdly enough, Pluto actually has a really large moon as well. Now, Pluto, now this wasn't known when we first discovered Pluto, although its moon is named Charon. And you see, it is around half the size of Pluto and around 10% the mass. And that is large enough that it actually makes Pluto orbit around it simultaneously as it orbits around Pluto. Since Pluto's still the much more massive object, it is closer to that barycenter, but it still is being dragged around basically by Charon. And you see, the thing about this system is that the barycenter is actually outside of Pluto. So that made astronomers think, where's the barrier between planet and moon, or binary planet and moon? And what they decided is that where the moon is, or the breakoff point between the planet and the moon, is if the barycenter is inside of the planet or not. Now, this is why most astronomers consider the moon a moon, although, like I said, it is around 70% of the way outside of the Earth's crust. So that is, so it's like it's a gray area, although it just barely isn't a planet in that definition. But I wasn't satisfied. The moon feels like a planet. Kind of. I mean, like, look at Mars's moons. They're so much smaller. And, I mean, if you consider the moon a planet as well, it actually fits perfectly with the terrestrial objects in size as well. You just have the smallest of the 5 terrestrial planets, per se, and the largest one, or orbiting the largest one of the 5 terrestrial objects. Although then I realized something. You see, the moon, so you probably learned this in elementary school, or at least I did, but the moon is slowly creeping away from Earth. And I'm pretty sure, if you remember earlier from the video, I said that one of the factors of where the barycenter is distance. Now, the moon started off really close to Earth, like around 13,000 kilometers, I think. I don't know, I could be making that up. I source how the universe works. I don't know. It was multiple years since I saw it, but saw that statistic. Although it's slowly after those years gone further and further away. Basically, now where it started was 0.5% of where it is now. So basically, throughout that time, the barycenter increased like almost 200 times, since you also have to factor in the radius of the Earth. And it will continue to do so. And in a few billion years, it will go outside of the Earth. So now we have this case where we have this planetary object, literally the one closest to us, and even though it might not be considered a moon now, in a few billion years, it technically would. So would we consider it a planet just because it will be considered a planet eventually? Or not? By the way, I should drop some merch. Just the moon's a planet. That's it. That'll sell out really quick, I bet. I have one problem. You see, if we go to Neptune, hold on. and go to its moon, Triton, something kind of similar is happening here with the Earth and Moon. Now, something to note is that Triton is nowhere near as large as a percentage base as the Earth and the Moon, but it still is relatively large in comparison compared to most other moons. Now, Triton is a weird moon. It is actually suspected that it came from the Kuiper Belt. Basically, it was like another Pluto, which is captured by Neptune, because it orbits retrograde to its planet, unlike most other moons. So, basically, what's happening with the Earth, with it going further away, is the exact opposite thing is happening to Triton. So basically, by that logic, in a few billion years, Triton would collide into Neptune. So basically, if we consider the moon a planet, Triton also does not exist. I should launch some merch. Triton doesn't exist. That'll confuse. I know that'll confuse a lot of people, but I love it. Although, if you really want to get like nitpicky about planetary classifications, Triton also is kind of a gray area because, like I said, it's theorized that Triton is a captured dwarf planet. So, do you consider it a binary planet system between a dwarf planet and a planet? I don't think so. I'd probably consider it a dwarf planet orbiting a planet. So it'd still technically be considered a moon. That's kind of how I see it, although Triton was once a dwarf planet. We don't even need to go to Neptune and even look in billions of years to see moons disappear. Like Mars's moon Phobos currently orbits very close to Mars. It is only in a few million years it's predicted to collide into it. So, yeah. Mars's moon Phobos also doesn't exist with that logic. But this is where I think there's a problem when it comes to classifying whether an object is a moon or not, because it really relies on the distance. Like I said earlier, since the moon is going further away, even though the distance where the barycenter is still in the Earth's crust, it won't be in a few billion years. So what I think the new approach should be is at the maximum point where the planet. Now, this also has some flaws, I'm pretty sure. I am not an expert at physics. Okay, even though I'm majoring in it, I'm switching next year. I'm just not good at it. But I'd like to hear an astronomer say something about this on whether it's feasible or not. It should be if that object was placed basically in the maximum point at which it can still orbit the object it's orbiting, if the barycenter will be outside of the crust or not, because now you have to deal with the distance between two objects, because it's not fair if there are two different objects which are the same mass. Because let's see, there's two different systems, right? There's one which has two objects. They both have two objects, and both of them have the same masses and the same ratio between the masses. Although one's further away than the other, and one of them causes the barycenter to be outside of the planet, although the other one doesn't. Is one considered all of a sudden a moon while the other one a planet? Like, how are we supposed to, where's the logic there? Now, like I said, there are issues with this, as the sun's gravitational pull is weaker the further away you are at the sun. So, like, for example, if the Earth was in Neptune's orbit, the moon could probably be a lot further away than where it is now. But still, I think there should be some sort of standardization which relatively eliminates the factor of distance. So that's more fair. Am I biased? Probably, but who knows? And lastly, we called the moon, and we called other objects which orbited other planets moons. So what the hell will we call the moon? Well, I've got a simple answer. It also kind of has a lesser known name, and that is Luna. We can just call the moon Luna if it loses its moon status. And that way we can still call other objects which orbit other planets moons, while we just call the moon something else, since it's not a planet anymore. And that's a relatively shallow dive into probably the stupidest theory I have personally. I mean, if you have any things which you believe like that, which you think are stupid, please let me know in the comments. So I hope you guys enjoyed this video. Make sure to leave a like, subscribe to my channel, and I'll see you guys all in the next video. Peace out!